Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request you please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now question, this reagent, what is its name? Its name is ethyl diazo acetate. It is actually a ester. Ester means this part is carboxylic acid ester, ethyl ester. So that's why ethyl diazo acetate. Why diazo? Because two nitrogen. Diazo means, remember student, di plus azo means two nitrogens. Azo means nitrogen, di means two. So two nitrogen atoms, yes, so diazo. By the way, it has a difference between diazonium salt. Diazonium means there is a positive charge on nitrogen. It is a neutral. See, N2, there is no charge on this molecule. Okay, so this is a unique. Now in benzene, in terms of benzene as reagent as well as solvent, metal catalyst, HNU or heat, what is the product? That's the question. So first let's look at the reaction. So if you look, let me draw this ethyl diazo acetate again. So actually it looks like this one. Remember, we need to check the valency. That's why I have given this plus and minus on this nitrogen. Now here this nitrogen is tetrabond, it has tetravalency, it attached to two carbon, two nitrogen, that's why plus, and this nitrogen is attached with this nitrogen is a double bond, that's why it's a minus. Now what happens actually, if in terms of metal catalyst, if you give irradiation or heat, it means you are supplying energy. What happens? This bond gets broken down. Okay, so broken down, it produces nitrogen gas plus this thing is called as carbene. Okay, so this is a carbene. Now why this nitrogen comes out? Because nitrogen triple bond is one of the very stable bond. Remember student, this is the reason why diazomethane are explosive, diazonium salts are not stable, same reason. So this nitrogen bond is very stable, so that's why it comes out. Second thing, it's a gas molecule, so it comes out from the reaction mixture, so equilibrium shifted towards this product side. Now so here if you look at, this is actually a carbene, and we know this carbene are reactive reaction intermediate, so they are very reactive intermediate, so they reacts, and here they reacts with benzene. Now you will be little shocked, sir, it reacts with benzene. We know benzene is an aromatic molecule, very stable molecule, then why it reacts? Remember student, this carbene is very much reactive, that is the reason. So that's why what happened, this carbene reacts with this benzene. So you may think like that, first it attacks, then this bond goes, so it is like a carbene reaction with alkene and formation of a cyclopropane ring system. By the way, I've already discussed a dedicated lecture on this. If you feel any difficulty, you may visit the corresponding video. Now I shall provide the link in the I button as well as description box. Now you will say, sir, why you have drawn in this way? Because this carbon is student sp3 hybridized right now, there are two hydrogens below. I mean previously there were two hydrogens which we ignore, so it is there. Now it is actually not stable. First of all, the resonance stability of benzene is gone, that conjugation, and second thing, three member ring, it's not that much stable. So what happened in the next phase, net phase, it's a electrocyclic ring opening, just you may consider it's a ring opening reaction. So what it can result, so this you can expect that this double bond will push, this bond will break, and it will go there. So in this way, I suggest you student, write everything as it is. Later on you do the modification. So there is one hydrogen here, one hydrogen here, one double bond here, one double bond here, this is, and it is attached to this acetate. Oh, Etn, obviously there is one hydrogen too. Let me draw it little differently. So it's a 7-member ring, so draw it little carefully. Now so we have drawn the 7-member ring here. Next is COOET, fine, and 3 double bond. Look at the carbon where ester is attached, that is a sp3 carbon, so do not get confused, it is a sp3, and alternatively this 3 double bond, this is actually a cycloheptatriene derivative. By the way, this is not aromatic. Remember, you may observe some stability because of homoaromaticity, but it is not aromatic because according to Huckel rule, cyclic planar, it's not planar, sp3. Conjugated here, not conjugated, sp3, no p orbital. so that's why it is not aromatic. So this is actually the answer. So here what is the answer? Obviously 7-member ring at with this sp3 carbon attach this ester group. Okay, so this is the answer. Now if you know this thing, sometimes we may get confused what will be the product. Look at benzene attached to this thing, and here carbon number is less in option A, so it's a wrong option. Student, if you look at the problem little carefully, you will find that wrong options are given. If you look at here, carbon number is also, it's a functional group change, ethyl ester was there, so here 3 carbon oxygen attachment, it's a completely bogus option. So actually these two options are very wrong option, but I think at the beginning you got confused. If you are really agree with me, write in the comment box. Now option C versus D is the real challenge, but during the mechanism I have explained that during this electrocyclic removement you observe that these sp3 carbon will be attached to this ester moiety. So this is the answer, not this one. This problem is little unique, and this is interesting because using this problem you can convert one benzene, means this 6-member ring into a 7-member ring. So this is actually, student, example of ring expansion. Okay, and this 7-member triene has some very unique properties, like cation is aromatic. I have uploaded lots of lectures regarding this. I shall provide the link and the playlist. Please visit for further understanding. So this is the end of the discussion. Thanks for watching. See you in my next video. Bye bye.